Okay, this will be the wrap-up for Chapter 2, and we're going to talk about translation from natural language to logic symbols, and also kind of give a recap of the chapter. Okay, so let's talk about translation. So I'm going to again define a proposition vocabulary. C represents the person is cool, F represents the person is funny, and P represents the person is popular. So I'm going to write a natural sentence here and a logic sentence here. If a person is cool or funny, then she is popular. And then that should be translated like this. So helping students to understand this, if we see the if-then, that means an implication. And everything between the if and the n is usually the antecedent, and anything after the then is usually the consequent. That's how we think about it. A person is popular only if she is cool or funny. Well, the only if means that we start, a person is popular only if, so popular then comes before the only if, that means it is the antecedent, and either cool or funny is the consequent. And so when you see that written in English like that, that's how you translate it. A person is popular if and only if she is either cool or funny. Okay, the if and only if is the giveaway. And you could write it either way, by the way, frontwards or backwards, however, because they're the same. So this is how you would say a person is popular if and only if she is cool or funny. That's the same as saying a person is cool or funny if and only if she is popular. Okay, there is no one who is both cool and funny. So no one, that's a negation. Cool and funny, that's a conjunction. So here's the conjunction of cool and funny. Here's the negation. So saying there is no one who is cool and funny. Okay, let me go back to that. Writing natural language sentences and translating them to logic is difficult and takes some practice. In my experience, students, the more practice they get doing this, the more comfortable they start to feel with it. And one of the activities that I'll provide for you is encouraging them to make up their own sentences. Now, you're going to give them a variety of sentences, but then encourage them to make up their own sentences, and then challenge them to see if they have correctly translated them. Sometimes you have to be careful by telling students that any sentence that you write, and they're almost always going to write sentences about their own world, and that almost always is going to include their friends. So any sentence that they're going to write that includes other people has to be respectful, and has to make that other person feel better about themselves, not worse. Because you can have kids write, inappropriate sentences. Okay, so a recap for the whole chapter. We talked about proposition constants, the kind of basic building blocks or the syntactical building block of propositional logic. It's any statement about the world that can have either a true or false value, but not both simultaneously. Compound sentences are formed from those simpler sentences and logical operators. If you remember, we had 5 types of compound sentences or 5 types of operators. We had the negation, the conjunction, the disjunction, the implication, the biconditional implication. We have a truth assignment, which is a mapping or an assignment of a truth value to each of the proposition constants in the language. So if you remember in our world that we created, sometimes it was true that the animal was a fish, the animal ate fish and the animal was a bird, but not true that it could fly. So the propositional constants there were eat fish, was a bird, could fly. And we assigned truth assignments to those, and there were 8 different possibilities if you remember our truth table. And we also went a step further by trying to correlate or map our understanding of what those truth tables meant onto the natural world. Okay? When we say satisfies a sentence, we mean a truth assignment satisfies that sentence if and only if the sentence is true under that truth assignment. So if I give a truth assignment to all of the proposition constants and it makes the sentence true, then we say that truth assignment satisfies the sentence. So we go through this process to determine the truth value of a complex sentence. It's what we just did in the last video. And it tells, based on the truth values of the proposition constants, it tells us whether the sentence is true or false. That's called evaluation. So you could say, let's evaluate this sentence to see its truth value given these truth values for the proposition constants. Satisfaction is the process of determining for a complex sentence whether there is at least one truth assignment for the proposition constants that satisfy the sentence. Okay, so you look through, and the way we did that was by using a truth table, and you look for the sentence truth values and determine, is there any, at least one, or maybe more than one, set of truth values that leads the sentence to be true. That's satisfaction. Thank you very much.